Okay, so now we're going to talk about another method for factoring by grouping. Before I get into the steps for factoring by grouping, I want to look at these two examples and look at how they could be factored. So when I look at the first example, we've talked now about how we always look for a GCF when we're trying to factor. So looking at this first one, I notice that my first term and then my second term both contain a 2x plus 1. In the past, we've looked at pulling out GCFs that are monomials. For example, a 2x or 4x cubed. But a GCF can be anything that both terms can be divided by. And in this particular instance, I see that both of these terms could be divided by a 2x plus 1. So I'm going to take that 2x plus 1 and I'm going to pull that whole thing out to the front. Since it is a binomial as opposed to a monomial, when I pull it up to the front, I want to pull it up to the front with parentheses. And then I'm going to ask myself, okay, now that I've taken that 2x plus 1 out, what's left? Well, when I divide 3x times 2x plus 1 by 2x plus 1, I'm left with a 3x. Similarly, in the back term, I'm left with just a 7. If you remember, our goal for factoring is to create a multiplication problem. Haven't I successfully created a multiplication problem in the form of binomial times binomial? If I look at the second example here, I would like to do the same thing, but the first thing I notice is that I don't have a GCF. There isn't anything that both terms could be divided by. However, these look very similar. So similar, in fact, that I recognize that x minus 1 and negative x plus 1 are opposites because my x and negative x are opposites and my negative 1 and positive 1 are opposites. Both terms have to be opposites in order to consider the whole thing an opposite. So I know that I could take a negative 1 out of one of my terms. Let's say I pull a negative 1 out of my back term. Then I'll have 4 times x minus 1. When I take a negative 1 out, it becomes plus 3. Negative x becomes x. Positive 1 becomes negative 1. And now I can see that I do have a GCF between my two terms. Both of my terms have an x minus 1, so I'm going to pull that x minus 1 out and ask myself what's left. Well, there's a 4 left from my first term and a 3 left from my second term. Again, because I now have a multiplication problem, I have now successfully factored this problem. I could take it a step further. I could say 4 plus 3 is 7 and change it to be x minus 1 times 7. That would be considered my simplest form after factoring. So we're going to keep these two examples in mind as we move into this process of factoring by grouping. First, I want to remind you of our so far steps. With our factoring, we're always going to first check for a GCF. We're always going to ask if we have perfect square minus perfect square with a binomial. And we're going to ask if we have a trinomial in the form x squared plus bx plus c. So we've got it taken care of binomials and trinomials, and we have our first step that we do no matter what. But now what do I do if I want to factor something with 4 terms? Well, here's some rough steps for you, and I'm going to run through them. I do have 3 examples on them. We're going to group the first 2 and last 2 terms together with parentheses and put a plus in between them. We're going to factor the GCF from each of the 2 sets of parentheses. And then we're going to factor one more time from each of our groups. So really we're going to factor 3 times. All right, so let's dive into it with this first example. Leave my steps on the screen. So first thing I'm always going to do no matter what is check for a GCF. I can see that all 4 of my terms do not have a GCF. So I'm going to go ahead and follow through these steps. So I'm going to group my first 2, and I'm going to group my second 2, and I'm going to put a plus sign in between. So it is not yet a multiplication problem. So now I'm going to, there's step 1. Step 2 is to factor a GCF from each of the 2 sets of parentheses. Well, my first set, I see 2x cubed plus 6x squared. The GCF there is going to be a 2x squared, so I'm going to factor that out. When I do, 2x cubed divided by 2x squared, I'm left with an x. 6x squared divided by 2x, I'm left with a 3. My second term, and I drop my plus sign down that I put in the middle, 3x plus 9 are both divisible by 3, so I take out a 3 and I'm left with x plus 3. Now, I'm going to move on to step 3. I'm done with step 2. Step 3 tells me do my two new terms, term 1 and term 2. So remember those two examples we just did? These look a lot like those two examples. Notice that I'm going to ask myself, do they have a GCF? And yeah, they both have an x plus 3. So I'm going to factor that x plus 3 out. And in my first term, after I take that x plus 3 out, I'm left with a 2x squared and a plus 3 in my back term, leaving me with my final answer. Let's look at the next example to do. I am going to move it up a bit, so when I move my screen up, I won't be able to see my steps anymore, but you should still be able to see them in your notes. So looking at the next example, I'm going to do the same thing. I check first for overall GCF, and I realize there is nothing that all 4 terms can be divided by. So I'm going to put parentheses around my first 2 and my last 2, and I'm going to put a plus sign in between. And now I'm going to ask myself, what is the GCF of my first group? Well, I realize that both terms in my first group can be divided by x squared. Taking the x squared out, I'm left with 5x minus 1. Remember that the x squared divided by x squared is 1. It doesn't just go away. I'm dropping my plus sign down. And now I have negative 15x and plus 3. Well, if I want this to work the way my last problem worked, I'm going to hope that after I take the GCF out of both of these groups, that I'm going to have a common factor. So I see that my first group, or my first factor that I got after taking out a GCF was 5x minus 1. If I take a 5 out, I see I'm going to have a negative 3x. I'm sorry, if I take a 3 out, I see I'm going to have a negative 5x plus 1. It will not quite match. So instead, I'm going to anticipate what I want, and I'm going to take out a negative 3 from both terms. So I'm going to say I'm taking out a minus 3, therefore negative 15x will become 5x. Positive 3 divided by negative 3 will become minus 1. And now I'm going to be able to look at my two new terms and say they both have a 5x minus 1 in common. So I'm going to take that 5x minus 1 out and ask myself what's left. Well, after I take a 5x minus 1 out of my first term, I get an x squared and a plus a negative 3. I know that plus negative 3 is the same thing as just subtract 3, so I'm going to write that as subtract 3 in its simplest form. I've successfully written a multiplication problem from my given polynomial. Looking at the last example, again, as I've said before, remember that I always have to first check for a GCF. And in the past two examples, when I checked for a GCF, the overall problem didn't have one. However, this polynomial, I noticed that all 4 terms can be divided by 8. So I'm going to start by taking a GCF of 8 out. Instead of taking it out with parentheses, I'm going to take it out with brackets, simply because I know I'm going to be having to put parentheses in my next step, so I don't want to deal with a ton of parentheses. But I'll be left with x cubed plus 2x squared plus 3x plus 6. Now I can go ahead and say, oh, I have 4 terms, so I want to group my 4 terms. So grouping my 4 terms, I'll group the first 2 and the last 2 and put a plus sign in between. This 8 out front is just going to keep dragging down with everything I do. So here's my 8, here's my bracket. When I look at x cubed plus 2x squared, I see they have a GCF of x squared, so I'm going to take that out, and I'll be left with x plus 2. My plus sign here drops down. And when I look at my second grouping that I made, I see 3x and 6 have a GCF of 3, so I'm going to take that out, and I'll be left with x plus 2. Close my bracket. I now look at 1 term, 2 terms, and I realize they have an x plus 2 in common. So the 8 drops down again, the bracket drops down, and I'm going to say I'm going to take an x plus 2 out of each of my terms. And I'm left with an x squared plus 3. I can now leave it like this with the brackets, or now I can go ahead and say, well, the brackets aren't really necessary since the x plus 2 and the x squared plus 3 are already grouped, giving me a final answer of 8 times x plus 2 times x squared plus 3. It does not matter which way I write this. These are equivalent statements. So big thing, make sure you're first checking for an overall GCF, and then just follow your steps of grouping the first two and the last two, and then we're going to do look for a GCF 3 separate times.